In this lesson, students are multiplying a whole number by a decimal. They are going to be asked to do 3 different steps. They are first going to estimate their product, then they're going to use an area model to solve and compare that to the standard algorithm and the partial products that they get in the standard algorithm. So let's begin with 43 times 2.4. If I estimated this, I would round this down to 43, I would round it to 40. 2.4, I would round down to 2. And that would give me 80 as my estimated answer. Next, I'm going to draw an area model. To do this, we want to think about 2 4/10 in unit form. So right now it's in standard form, but in unit form, 2.4 or 2 4/10 is written as 24 tenths. So let's go ahead and use that information to help us draw an area model. I like to put my decimal along the top of my area model, so I'm going to put 43 on the side, but I'm going to break 43 up into my 1s and my 10s. So 40 plus 3 gives me 43. Now along the top, I'm going to be putting my decimal there. My decimal is 24 tenths. If I broke that up, that is 20 plus 4 tenths. It's very important that we label that these are tenths, because when we go to multiply, we want to remember that our product then will be in tenths. So let's go ahead and multiply. Let's start with our area here with 3 times 20. That will give us 60 tenths. Then I like to move across, and 3 times 4 is 12. Let's go on down to our 40 times 20, which will give us 800. And then 40 times 4, which is 160. Now I have all of these partial products that are in tenths that I need to add together. I like to add by row. Sometimes students will try to add all the partial products at the same time, and their numbers are not lined up, or they don't see that they carried, and they get the wrong answer. Let's add across a row, one at a time, and then add those 2 partial products together. This also lets us compare it to the standard algorithm, which you will see in just a moment. So as I add 60 and 12, I get 72. I need to remember that these are tenths. I can label that, or just keep them in my mind when I go to add it to my other partial product that my answer is going to be in tenths, because all of these are tenths. 800 plus 160 is 960 tenths. So those are my 2 partial products that I'm now going to add together. All right, and I'm definitely going to label this, because that's my final product, is 1032 tenths. It is written in unit form, and so we want to be able to write that in standard form. In standard form, it would look like this. Our 2 is in the tenths place. So we do have a total of 1032 tenths. This is our answer. Let's compare this to the standard algorithm. So that is the 3rd step students will take when solving these problems in this lesson. Students will be writing their decimal first in unit form. And so they'll be setting up their problem just like this. And it allows for students to solve this and ignoring that there is a decimal for now. So I can take 3 times 4 to get 12, 3 times 2 to get 6, plus 1 is 72. You can also see how adding across to my area model gave me that same partial product. Now I'm moving on to the 4. It's not actually 4, that's actually 40. So we put a 0 here to hold that place value because we're really taking 40 times 4, which would be 160. But putting that 0 there allows us to think 4 times 4. And 4 times 4 is 16, so I put my 6 there. And then I carry my 1. But there you can see the 160, right? Now I'm going to take 4 times 2, which is 8, and add that 1, which is 9. And again, you can see how my partial products match. I add these together, and I get 1,032, and these are in tenths. And so then I just need to rewrite this as we're in standard form. And my answers match. I also want to show you really quick. Really think about how we got that 72 tenths right here. You can see it in the area model. We took 24 tenths and we multiplied it by 3, which gave us 72 tenths. And then think about how we got that 960. So over in the area model, you can visually see that we took our 24 tenths and we multiplied it by 40, which gave us our 960 tenths. We added our two partial products together to get 1,032 tenths, and then we just needed to add our decimal to write it in standard form.